Alright, let's talk about inequalities. We can use this video for systems of linear equations and then linear programming. So we're going to call this a review. This is something that you probably saw in a previous course, but you haven't used inequalities in a while, and some of this may have disappeared from your mind, and we have to refresh it. So for the most part, what we've done before you watch this video is anything with an equal sign is an equation. Now we're going to talk about inequalities, and an inequality is something that has any of the following symbols. When I say symbols, specifically less than, greater than, less than or equal to, greater than or equal to. Okay. So A is less than B, A is greater than B. These are called strict inequalities. They don't have an equal sign. A is less than or equal to B. A is greater than or equal to B. Okay, so let's just remember what these things mean. So is 6 greater than 2? Is that true or false? You could look at these or think of these on a number line. 0, 1, 2, 3, 4, 5, 6, 7. And so like 6 is here, 2 is here, 6 is greater than 2. True. Okay, so if you want to think about it as a number line, you can do that until you remember the notation. And then I put this one in here as a trick. Not really a trick, but sometimes students get confused. 6 is greater than or equal to 2. Is that true? 6 is in fact greater than 2. It's not equal to 2, but it's greater than 2. So we have 6 is greater than or equal to 2. So yes, it is greater than. It satisfies that. The or means it could be this or that. Okay, it's not equal to, but it is greater than. So true. Okay. Likewise, and I'm just going to squeeze this one in here, pulling in audible. I'll do it up here. Is 3 greater than or equal to 3? And that is also true because 3 is equal to itself. It's not greater than, but it is equal to. So it still satisfies that. And is 15 less than 8? No. If you continue our number line, 15 is here, 8 is here, 15 is greater than 8, 15 is not less than, so that's false. Okay? So we need to know the difference between which statements are true or false, understand why. So, in the CoRec homework, you're going to have some examples where, to kind of build up the knowledge of inequalities, we'll have some exercises, some homework. So we'll also be graphing inequalities on the rectangular system. So we'll be graphing those on the full coordinate system. But before we do that, let's graph simple inequalities on a number line. So you'll see this in the homework. For these CoRec exercises, to represent the strict inequalities of less than or greater than, we'll use left or right parentheses. To represent less than or equal to or greater than or equal to, we'll use brackets. Now, what I'm going to do for you is this may not be as common as what you learned in a previous class. So I'm going to also show you another way you may have seen it. And if that makes sense to you, then that is perfectly fine. I will say you'll need to know this because that's what shows up in the homework and quizzes. But in a previous course, you probably used an open circle instead of parentheses. That's the same thing, so just remember the open circle is the same thing. The closed circle is the same thing as the bracket. 10. So I'll close my circle. So if you remembered it that way, just do it that way. Same thing with this. Here it has a parentheses for 10, x is greater than 10. You can use an open circle. And then here we have a bracket for a 10. You can use a closed circle. Okay, so that's also acceptable. So less than 10, you have parentheses or open circle. Less than or equal to 10, you have a bracket or a closed circle. Greater than 10, you have an open circle to the right, and x is greater than or equal to 10, you have a closed circle and shade to the right. Okay. All right. So they ask us to graph these on a number line. Fortunately, my understanding on the homework, it'll be multiple choice, so as long as you understand it, you won't actually have to graph. You just have to pick out the correct one. So when we graph these, we only have to really worry about the numbers that are on here. So 15. Oops, that's messy. 15. It says x is greater than 15, so using the notation for Pearson, greater than, we'll use a parentheses. I'll use a different color. Okay, and then we shade to the right. Again, what you probably learned in high school, maybe a different symbol. You could use the open circle if you'd rather do that. Open circle, we shade to the right. So just know those are the same. So both of those are acceptable. This 15 is right here, by the way. Okay. All right, now I have x is less than or equal to 5.6. I'll do this both ways again for you. Just to illustrate, it's the same thing you learned in high school, assuming you did it the same way I did it. All right, so 5.6 less than or equal to means we're going to shade to the left. It's the equal to, so we have a bracket. Again, I'm just referring to my chart. If it's less than or equal to, we have a bracket to the left. If it's less than or equal to, we could also use a closed circle. So, just two different ways to show the same thing. This is part A, this is part B. Okay, both of those are fine. Okay, so now that we understand that, let's transfer this to the rectangular coordinate system, which we're going to do down here at the bottom. I'll show a little bit of work before I do this graph. That's why I left us some space. Graphing vertical line inequalities. So this will show up when we talk about linear programming. And in the regular 1029 class, we sometimes just kind of breeze over it because we discussed it in the previous section of linear inequalities. So this is a good opportunity to take some time to explain what's going on. Okay? So, this is fine. We learned how to graph inequalities in the last section, not the last Corec video, but the last section in the textbook. As we prepare to talk about linear programming problems, we want to talk about this special case of vertical line inequalities. And I do it this way to make our life easier with linear programming problems. So let's consider x is greater than or equal to 2 and x is less than or equal to 5. at the same time. We're going to consider these at the same time on this rectangular coordinate system. I'll graph the final one here. I'll graph a few intermediate ones along the way. We're going to graph them at the same time, so the answer is the intersection or overlap of the regions. Okay. So x is greater than or equal to 2, and x is less than or equal to 5. Like I said, I'm going to graph these at the same time. So I have my line. I'll worry about transferring it here in just a sec. Let's worry about the line aspect. So let's put some numbers down. I need for sure 2 and 5, but you know what? I could go ahead and put 1, 2, 3, 4, 5, maybe another number, or 2. Okay. Because it's x, and I'll do this actually twice because I really like the closed or open circle, but I'm going to use what the textbook uses too. Okay. So I'm going to do this twice. And you can do whichever one you prefer. I just want to stay consistent to what you learned in school, and if I start using brand new notation, that could throw some people off. So, x is greater than or equal to 2. Okay, because it's greater than, we use a bracket. I'll just happen to have these here. So I'm going to shade to the right. Now notice I'm using like hash marks in one direction, and that's because I'm looking for the overlap. So when I go the other direction, I'll do different hash marks. Okay, that's x is greater than or equal to 2. X is less than or equal to 5. If we use this bracket, I'm going to put my hash marks the other direction. So the answer is where they overlapped. Okay, so the solution is between 2 and 5. That's the solution. Okay, that region 2 to 5. On this one, I'm just doing the same thing, but instead of brackets, I'm using closed circles. So 2 greater than or equal to 2. So I'm going to shade to the right. And then this one is less than or equal to 5. So I shade to the left. Again, I'm just changing the direction. It's the same idea, the overlap, where you can see the crisscrossing. Let's see. We got a 2. We got 5. And so the intersection is where they intersected, right? So this is the answer. But how do I relate this to the full graph? We'll do that in just a second. It turns out, before I get to that x is greater than or equal to 2 and x is less than or equal to 5 is the same, can be written as, and you may see this, 2 is less than or equal to x is less than or equal to 5. Okay. This is called an AND inequality, a 3-part inequality, because it's this and this at the same time. I like this because it's easy to see if x is living between 2 and 5, and I'll just use the dots. It's easy to see that x just lives between that. So that's one thing you can do is if you recognize that you have, the intersection here, you can write it that way. I just want to mention that because we'll mention that in linear programming. All right, so how do we translate this to this rectangular coordinates? Well, let's go ahead and plot these numbers. So we got 1, 2, 3, 4, 5. So 2 is here, 5 is here. I'm going to extend this up. Now these are closed circles, so that means I'm going to use a solid line. If these had been parentheses or open circles, I'd use dotted lines. Okay. And you know what? I'm going to do my final answer here. Before I do the final answer, I want to do one intermediate step. I want it to be clean. So we got if I kind of translate this to here, we got, say, 2, we got 5. Because these are solid, we're going to shade to the right for x equals 2. And we're going to shade to the left for x is less than or equal to 5. So I think by extending it here, it makes it easier to see our final answer is this in the middle. Okay. And in fact, that's what our final answer is. Okay. So that is one example of the type of three-part vertical inequality that you'll see.